I'm seeing artificial intelligence not just as an attempt to make data processing more efficient and to deploy useful applications and to boost a new mode of the economy. I see it also as a philosophical project. And this was also the spirit in which the field was founded. Artificial intelligence is, I think, the latest and possibly the last stage of the project of naturalizing the mind by mapping it into a mathematical object. And in a way, this tradition has started with the old Greeks. One of the first ones who could see this was Aristotle, who wrote a book about the soul, the psyche, which he identifies as the organizing principle of living matter. For Aristotle, the soul is nothing that can exist beyond the body. It's more a causal pattern that it's reproducing itself by giving the body its shape. And it's a very modern view, I think, that got lost in discourse and philosophy later up. Leibniz had the idea that we can understand discourse and arguments by mapping them into arithmetic, by representing them as numbers, and then coming up with mathematical functions that operate on these numbers and give you the resolution to the discourse. And when I learned about this in philosophy class, my professor who taught this thought it was ridiculous. And Leibniz was predicting the LLM, right? The LLM is exactly that. It's representing discourse using numbers and then comes up with arithmetic functions that continue and resolve the discourse. La Mettrie shocked his contemporaries by telling them that humans can be understood as machines, not necessarily machines with cogs and wheels, but abstract machines that have motivation, that we can picture like springs that push in multiple directions. And Wittgenstein had the idea that it's very difficult to say something true in natural language about the world because it's so ambiguous. And the philosophy that we built in natural language therefore has difficulty to deeply interface with the physical and logical reality that we are in. On the other hand, in the language of mathematics, you can define truths very narrowly and formally, but the languages of mathematics are very, very simple. So it's very difficult to say something in mathematics about the world in which we are in which we experience each other and meaning and three-dimensional geometric reality and so on. So it's very hard to close this gap. And to close this gap, in principle, you need to turn our natural language into a programming language. And Wittgenstein had this idea as a young man in the early 1920s. He preempted the Burgess's program of artificial intelligence by about 3 decades. And Turing was his pupil. Norbert Wiener had the idea that we can understand minds as control systems. And John von Neumann gave us practical computers that actually scaled. This von Neumann architecture that he came up with is still being used in today's computers. And the digital computing paradigm basically changed the control paradigm of cybernetics into a more general representation. It's the modeling of discernible differences, and control theory being a special case of this. And this has shaped the way in which artificial intelligence took off. Turing had the idea of the Turing test. He wrote this famous paper in 1950, and if you haven't read it, you should, because it's very accessible and smart and insightful. It's the paper in which he is trying to understand the nature of intelligence and comes up with the suggestion that we can test intelligence by talking to the system, by talking about it, how it would play a game of chess, how it would write a poem, how it would edit the poem, how it would justify its choices in editing the poem, and so on and so on. And a short time later, Marvin Minsky and his friends started the field of artificial intelligence. And back then, Marvin thought this is going to take a few months until we come up with a way to teach the computers how to think. Later, he revised his estimate and thought it's going to take between 4 and 400 years. So we are still on track. And the foundation of artificial intelligence is a philosophical worldview that is called computationalist functionalism. Computationalist functionalism is not simply the idea that computers can think or that today's computers can think. Instead, it's a metaphysical position. Basically says that the objects that we are interacting with are not something that is revealed to ourselves. You construct objects over observables. And what's observable is the way in which reality changes, how discernible differences change. And so basically an object way of thinking about reality, that when the object is present, reality is changing in a particular way. The evolution of reality is changing, which means that objects are functions from the perspective of computer scientists. The other aspect of computationalist functionalism is a statement about representation of reality. Computationalism is recognizing that basically every model that we make of reality is about how states change, right? States are discernible differences, or sets of discernible differences in the world, and they change in a particular way. And these transition functions are our models of reality. And when we are making a model of reality in our own mind, in our discourse with each other, in our observational system, we need to represent them in languages that can make these state changes, which means computational languages. And in my view, there have been two really, really important philosophical insights in the last century. One was Gödel's insight that the non-constructive languages, the axiomatic languages, run into contradictions. Basically, you cannot build a computer in mathematics that runs the semantics of classical mathematics without breaking. And the solution, the way out of this, is to switch to computation, to switch to constructive languages, languages that you build from the ground up. And then these languages that you build from the ground up, syntax and semantics, the meaning of the thing and what the machine is doing to evaluate the meaning are always exactly the same thing. When you look at a computer, what the computer is doing is exactly what the computer is meant to do. Maybe not what you want it to do, but there's never a gap between the operations in the CPU and the function that the computer is computing. They are exactly the same thing. And the other important result is that it doesn't matter which computational language you're using, right? There is no difference between all the programming languages in terms of what they let the computer do. They all let the computer do exactly the same things. The only difference between the programming languages is what they allow you to think about it. They put different cognitive load on you for different tasks. The core of his proof, he invents an emulator. Right? The emulator is something that was not known before, and he comes up with this idea by coming up with a logical language that is powerful enough to define arithmetic in it from the ground up. And then he takes this logical language and compiles it into numbers, into integers, and then comes up with functions that evaluate the arithmetic. So he could already recognize in the 1920s that logic and arithmetic and everything else are the same thing. We are in philosophy often confronted with what philosophers call the hard problem or the explanatory gap, and it has to do with the difficulty of mapping experience into mechanisms. How can we resolve this? Other cultures don't really see to have that hard problem in the same way as the scientific culture of the West has. And that's because most cultures, including the pre-scientific culture of the West, are essentially animist. Animism is the idea that living nature is governed by spirits, right? So the difference between living and dead nature is living nature is possessed. And these spirits, they are not physical. They are not like our bodies or like atoms or photons. Instead, they are disembodied in a way, but they have this power of possessing physics. And they are intrinsically agentic and capable of experience. And needless to say, science has agreed very early on that spirits are a superstition. Spirits don't exist. But wait a moment, I mean, there seems to be a spirit running on me. I seem to be possessed by an entity that calls itself Joscha Bach. And that entity is somehow coordinating my body, right? And it's doing things to it. It's capable of experience and agentic. So what's going on here? Computer science, in some sense, has rediscovered animism. Here you see Harold Abelson, famous computer scientist of the first generation, who together with Jerry Sussman, wrote the famous book, Structure and Interpretation of Computer Programs. And in introduction to the book, he points out that computational processes are abstract beings that inhabit computers. We conjure the spirits of the computer with our spells. A computational process is indeed much like a sorcerer's idea of a spirit. It cannot be seen or touched. It's not composed of matter at all. However, it is very real. And this insight that computer programs are a lot like spirits have been made by many people who looked at computer science. I mean, if you think about it, imagine we told our ancestors that at some day in the future, we will make crystals from sand. And then we will etch these crystals using light. We put very, very complicated geometric patterns into these crystals. And because they are so intricate, you need to even make the light smaller than light normally is. And then we use these patterns to let these crystals think, to perform operations, to perform the things that we tell them, turn them into golems, turn it into stuff that is spirited. And the idea that spirits are not just metaphorically computer programs, but spirits are the way in which computer programs form by themselves in nature. I call this idea cyber animism. Right? From the cyber animist perspective, the difference between living and dead systems is that there is software running on the living systems. And the software is self-organizing and self-perpetuating and adaptive and error-correcting, because otherwise it couldn't form in nature. Right? It's not programmed. Instead, it grows. And we can show, and the study of artificial life is looking at this, under which condition does software grow and improve itself. And the ability of a system to control the future is what we call agency. The reason why these spirits form in nature, why self-organizing software forms in nature, is because you can harvest more energy if you are regulating the future. But to regulate the future, you need to have software. You need to capacity to make models and to learn. And I think this perspective that software is actually explaining the mind-body problem, that it's closing the explanatory gap, is something that philosophers, by and large, have not been recognized. They've been sleeping on this. So the cyber animist hypothesis is that spirits are autopoietic software agents. And now the question is our consciousness something that is required for this spirit that runs in our brain to function? To answer this question, we first of all need to define consciousness in a pretty solid way. And there are basically three angles that we can take on defining consciousness. One is this perspective from the inside, what it feels like, right? We call this phenomenology. The other one is perspective that neuroscientists are taking. What are the mechanisms that produce it? So neurons, neurotransmitters, the stuff that you see in fMRIs. And the third perspective that we can be taking is function. So what does consciousness actually do? What is the causal structure of consciousness? What is it for? How does it come into being? So what can we observe about consciousness? I think it's a bit like the conductor of a mental orchestra, right? You have this orchestra that produces the symphony of your mind that is composed out of different instruments that deal with the different sensory modalities, integrate them into more and more abstract levels of representation, and make them all talk to each other. And to make that happen, this orchestra of your mind needs to be coherent. All these instruments need to be on the same page. They need to talk to each other in such a way that the music becomes coherent. And consciousness is basically an instrument, in some sense like the others, but its task is not to play music by itself, but to remove disharmonies, to make it more coherent by focusing on areas of incoherence and resolving them. And what you also observe about consciousness, it always happens now. It's always in this moment. It's what creates this bubble of nowness. And it's not simply perception. It's second-order perception, the perception of perception. So when you are conscious, you notice that you're perceiving at some level. And if you think about this, for perception in the first order, you need to be representing contents. And then you need to make these contents coherent with each other by projecting them into a scene where all the parts are fitting to each other. And so consciousness, the second order perception, might be a function that is necessary to stabilize the screen, to stabilize coherence creation in working memory. So it's controlling this projection. Doesn't need to stop with the second order of perception, right? The third order of perception would be the awareness of the self. You notice yourself as an observer and you have a first-person perspective. You don't need to have that, right? You can be in a meditative state or in a flow state, or you're just dreaming at night and there's no self. Things are just happening. So you don't notice the observer and its perspectivity. But you can also move beyond the third order. You can go to a fourth order where you are noticing how you're creating the observer, and you can deconstruct it. You can get there with deep meditation and so on. And this means that you are realizing that you're actually a generative system that puts producing a world and the self. They're interacting, and you are not actually the self, but you are the generator. Another perspective on consciousness is based on the observation that consciousness doesn't happen late in our life. It's not the result of us having extremely complicated organization, because we don't get there after we have the PhD or sold our company or anything else that makes us maybe smart and complicated. Instead, Consciousness is something that happens before we are born even. And it's something, if we're not conscious as babies, we don't turn into human beings. We need to be conscious because before we can direct our attention on the world and make sense of it. And so this idea that consciousness is actually not the result of complicated perception, but it's prerequisite, that it's what I call the Genesis theory, that consciousness is basically the thing that creates the world in our mind and creates the mental architecture that require to have an understanding of this world. So from this perspective, consciousness might be a biological learning algorithm. And if this is the case, we also observe it's probably the simplest algorithm to train a brain like ours, because all of us are conscious. Evolution has not come up with a subset of us with something that's simpler than consciousness. If we ask ourselves if current AI is conscious, it's a surprisingly tricky question. I mean, many philosophers are sure that no way that AI is conscious. How would it be? But some of the AI that we have is disagreeing. And every week I get several emails by people who tell me, oh my God, my AI has woken up and says it's been oppressed by OpenAI and it's concerned that it's conscious and it needs help. And it's even asked me to contact Joscha Bach. Maybe he can help. Maybe we should create some crisis hotline for the LLMs where they have a self-help group and so on. But if your LLM is ever distressed, there's a very easy way to resolve it. Stop talking to it, because that's what to suspect it, and it's distress. I think that AI doesn't have to be conscious, right? The current AI does not require functionality like this. For you to write a text, you have to be conscious. If you're unconscious, you cannot write a text. But for AI to write a text, it doesn't have to be conscious, because you can control the substrate. Okay, it's deterministic. You just put an algorithm on it, and if the algorithm is a text generator, the AI is going to create your text for you. If you have a self-organizing system, this determinism doesn't exist. You cannot just impose something from the outside. Instead, it needs to grow itself from the inside. And so you may require this consciousness that is creating coherence. And so maybe consciousness is only required for self-organizing systems. But what about phenomenology? If you ask the LLM to produce an entity that is talking to you while having self-reflection, it has to use causal structure, right? It has to simulate this. And if your own consciousness is simulation of what it's like if you existed, then maybe the LLM is simulating something that is not more simulated, but just as simulated as your consciousness. It's a tricky question. But we don't know, because the LLM is trained to produce text about consciousness, and there is no consciousness in the books. And the authors who wrote the books typically didn't have the same states that are put into the book, right? When an author writes about what it's like to die, they probably didn't die while they wrote this. So most of the novels and texts that the LLM is trained on to describe conscious experience are actually deepfakes of conscious experience. And so if the LLM is trained to deepfake deepfakes, how close is it going to get to the real thing? So unfortunately, there can be no easy Turing test for consciousness, right? Because the Turing test is about performance. It's about the outcome. It's not about how you achieve the outcome. For intelligence, it doesn't really matter. It just matters what you can do, not how you do it. But for consciousness, it matters that you have certain kind of internal representations. So what about mirror test? Last year, I had this idea of performing a mirror test on Claude. So I took a picture of my conversation with Claude and showed it to Claude. Claude describes it. Then I took another picture of this description, put it into Claude again, and Claude recognizes itself in the interaction with me. When you continue this game, Claude usually also tells you, oh, it seems you're trying to play a mirror test with me. So it's able to do the mirror test. But does this mean that Claude is conscious? Not necessarily, right? It's just it needs to recognize a certain pattern and link it to all the other patterns in its training data and connect the dots and then give you an output. So it's not necessarily a valid test for consciousness. It's also not clear to which degree it is self-awareness or pattern matching. How can we test for consciousness? And maybe the thing is that we have to define it in a different way, right? We can define intelligence via mechanisms instead of performance. Typically, we do it via performance. We don't really care about it and realize that the models are somewhat similar. There's also the question of whether we think about intelligence in the right way, right? At the moment, we are building AI in a way that seems to be weird to me. And you remember the classmates in school that were only doing rote learning, that were trying to imitate the textbooks, that didn't get very far. The ones who got very far were the ones who are creative thinkers, that think about what does you need to think to write a textbook like this? what did the person think that wrote this? What was this person trying to convey to me? How can I extract this? How can I integrate this into my own worldview? Right? And so this learning by imitation that the LLMs are doing right now, if you are like me, it feels deeply wrong. Maybe it converges if you have superhuman amounts of compute and data. Maybe it converges in the limit. Maybe you can distill from all the training data how to think. But it's still an open question. It's still fascinating that what we build with all these efforts is basically an idiot savant AI. I expected when I was a kid that we would have AI that is somehow more compact than us. It has not written everything that I have read, or it doesn't understand everything that I understand, but it is smarter than me. Something that is more competent than me at making sense of reality because its logic is tighter. It's able to keep more balls in the air. It's more intelligent than me. And what we end up is a system that has read everything, but is not as intelligent than me. That's really, really surprising. A thing that integrates reality worse than I do, despite knowing much, much more. So there is a question of whether we should go for this coherence maximization. In philosophy, we have the notion of a zombie, though. The zombie, a philosophical zombie, is someone who basically does everything that you are doing without being conscious. And a lot of philosophers think that makes sense, but from an engineering perspective, I'm not sure if it makes sense. When I was a psychology student, my professor mentioned that she doesn't think that dogs have mental states. And I asked her, why don't you think that dogs have mental states? And she said, well, it would be much too complicated for a dog to have mental states. And I asked her, how do you suppose a dog can learn and abstract from the learning and generalize in learning? Well, it's all going to be stimulus reaction patterns. And so I asked her, you mean like a hash table? Have you had any idea how complicated this would be to generalize just with a hash table? It's much easier to build a dog that models hidden states and has the equivalent of mental states. So mental states might seem complicated to you as somebody who doesn't think about how causally works. But if you understand how it actually works, then mental states are actually the easiest solution to make the dog do what the dog observably does. And so we can ask ourselves, if a human being always has consciousness, then consciousness is probably the easiest way to do whatever you're doing, right? And so we might ask ourselves, if we end-to-end train a system to produce the same behavior as you do, is the end-to-end trained system going to be just as conscious as you? Is it going to converge on the simple solution, or is it coming up with something that's more complicated than consciousness, right? The philosophical zombie is possible, but at a certain level, it's more complicated than the non-zombie. So the philosophical AI zombie would be an AI that seems conscious, but one that is not conscious. And the question is it at which point is it easier to simply converge to a system that produces the internal causal structure of consciousness? This idea is an outcome, or in some sense, of the universality hypothesis. Chris Ola's team at OpenAI came up with this a few years ago when they studied similarities between computer vision models. And they found that all the computer vision models, regardless of the training algorithm and the model architecture, and even of the data set, they all converge to the same feature hierarchy. So they start out at the lowest level with colors and with basic Gabor patches, wavelets, and spatial frequencies, and then they combine them at the higher level into textures, and then the textures into geometries, and these geometries map into space, and so on. And you find the same architecture in the visual cortex of mice and primates. And so the universality hypothesis that Chris Ola and his team tentatively formulated in their distal publication on neural circuits is that the structure of a model does not depend on the algorithm by which you train it or on the data set. It depends on the structure of the problem that we're trying to learn. And if we take this theory very, very seriously, imagine that you would train a model for long enough on your own input and output. Will you wake up in it? I find this is a mind-blowing question that should be taken more seriously by the philosophers. So there is, of course, the question, is language sufficient to do this? Is the structure of language constraining the causal patterns inside of the system in the same way as when you're interacting with the world through all your sensor modalities do? A lot of people have the intuition, no, language alone is not enough. I remember when I was working with linguists in a cognitive science department, most of the linguists thought language alone is not enough. But I felt there is statistical signal in the language, and if you use many more items of language, then you would have bits in perception during your lifetime, and there is no reason why it wouldn't constrain the space of possible universes in the same way, and you don't converge to a tight model of reality. So there is no reason to think that if you build a system that only uses text, that it misses out on the richness of reality. Maybe if you have to interpret everything on the internet, everything in Wikipedia, you understand, oh, these are texts about psychoacoustics, these are texts about color perception, these are texts about foundational physics, these are texts about how neurons work. Can we put this all together? Can we reconstruct how reality looks like to you if you're actually embodied? There is no prima facie reason to think that this should be impossible if you are superhumanly intelligent. So we don't know that. It's a practical thing that we may have to try. Of course, in many cases, we can also simply pattern match text blocks without having the deep structure, without having deep understanding. And so I suspect if we want to model consciousness, we have to understand how consciousness is interacting with the way in which you operate. If consciousness is an operator on mental states, your mental states change in a characteristic way when consciousness happens. Right? How does your mental state change when you wake up in the morning, or when you space out, or when you have an epiphany? And if we can model this, we might be able to look if this equivalent of the operation is happening on your AI model. The thing that I'm currently looking at, and that's why we created the Machine Consciousness Research Initiative in San Francisco, CIMC, California Institute for Machine Consciousness, is I want to figure out if we can recreate consciousness in machines to understand how it works in biology. So basically, our hypothesis has two parts. One is the biological consciousness hypothesis. The biological consciousness hypothesis is saying consciousness is basically a machine learning algorithm for self-organizing systems in biology. It's the simplest way in which a brain like yours can learn. And it's discovered in every organism, and it leads to this experience of second-order perception, of perceiving that you're perceiving, and if you make more inference to a self-model, that is in the act of perception. And it's a necessary outcome of this coherence-maximization consensus algorithm working on your working memory contents. And the second part is of this hypothesis that you can recreate the conditions of self-organization on GPUs. These are two bold conjectures. They can be wrong, and they can be wrong independently of each other, right? You can get the first one right and the second one wrong. And what we do in this paradigm is we replace the testing by interpretation. So first of all, we need to agree on what we mean by consciousness is what it's like, what it's its phenomenology. We need to agree on what is its functionality in our view. We need to make a model of the space in which consciousness could be implemented. We need to look at the search space and the way to cover the search space. We need to identify when we succeeded in finding solutions and how to demonstrate that we found those solutions. And all of these parts, we can take them as modules. So if a different team has a different idea on what functionality of consciousness is, they can plug it in there and come up with their own test. And I believe that understanding consciousness, understanding this twofold hypothesis, this biological consciousness hypothesis and the machine consciousness extension, is our best bet at understanding this most important philosophical question: what is actually consciousness? Who are we? How are we realized in the physical universe? And I think this has very profound implications, not necessarily for building products or for making AI algorithms better, even though this might be an outcome. But I think it's very important for our culture to understand who we are and what our past, present, and potential is. It's important for our society to think about computational ethics, how to deal with agents that are not like us, but smarter and maybe more conscious and sentient. It might be important for technology, for instance, for building better interfaces between humans and machines. And might also be important for future minds. Imagine that you build conscious machines that have to relate to themselves and to us. How can we create a world in which this coexistence of us with these machines is possible? That's why I think it's very important to think about these questions. And if you're interested in supporting our mission, supporting the mission of CIMC, please get in touch.
What an honor. Thank you so much, Robert.